Oh, hey there! I guess you want to hear about the cherry picker drone arm. Well, it's funny you ask. So there's a giant scenario going on where there's a bunch of fruit that can't be harvested, or can be harvested, but it takes migrant workers to pick it. So our goal was to take an arm, put it on a drone, and to harvest the fruit and bring it back to a base location. And this would eliminate the need for migrant workers to go out and harvest all our produce. Another benefit that will come from the arm is it'll reduce the number of times human hands have to touch it. So that's reducing the number of times or the chances that a disease will be spread throughout the consumers of the produce. So our design was quite simple. We ran into a couple problems, but I'm going to turn it over here in a couple seconds to Jacob Eden, and he's going to talk about our design.
Thanks, Tate. Today I'm going to talk to you about the decision-making process that led to our current drone design. Here at the Flying Farmer, we believe in providing high-quality products using the most durable, lightweight materials. Specifically, we utilize lightweight carbon tubing and fiberglass components. Before we arrived at our current iteration, we ended up discarding 3 promising ideas. The first one utilized 2 shear blades to slice through the stem of the fruit we were cutting. This ended up being problematic because the weight of 2 shears required 2 separate servos and too much power for our small battery. Our second design used 1 shear blade and a flat surface to cut against, but this required a more powerful rotor that our battery could not power. Our third design ended up using the same shear blade and flat surface, but a linear actuator to cut through this. In order to have a linear actuator strong enough to push this blade closed, we needed a much more powerful battery. Our final current design utilizes a rotary blade that simultaneously pulls in and cuts through the stem of this fruit that we're harvesting. Now it's off to you, Kendall.
This is our final design. I'm going to start at the left end and work my way down. You'll notice the base here is pretty wide. I kept this wide so we could mount it to either one of the drones really if we needed to. This is all fiberglass. On this end we have the battery. I moved the battery further back this way to kind of help counterbalance the design. Then we have our receiver here, our speed control, and we use a single servo for the arm down here to actuate the bucket holder, I guess. This tube is carbon fiber. We used composite materials for this because it's probably our lightest and strongest option. On this end, you'll see we have a small brushless motor here that is well capable of spinning up this small rotary blade. Here's the guides that will guide in the stem of whatever berry or fruit that we're intending on picking. This motor can spin at about 15,000 RPM, but our blade is only recommended for 6,000, so we're going to try to keep the throttle lower. So I'll give a little quick demonstration of how this all works. This is our holder for our collection bin, and it just moves back and forth to hold the bucket or release it. Here's our motor here. I'm going to key it on real quick so y'all can see it. And that should be more than enough to get the job done. So.
Thank you, Kendall. The following are potential improvements to the prototype in order to release our product, the Flying Farmer, to the market. First improvement. Our group thought of altering the shape of the drone in order to get closer to the tree in which the produce we're picking from. In order to incorporate this, we moved the propeller of the drone backwards so that we can flatten the front of the drone. Second, we want the drone to be more stable. Shortening the cutting arm will improve the drone's center of gravity. Also, incorporating a better IC chip will better correct the drone's motion. And thirdly, we like to elongate the flying time of the drone. A more efficient battery and repeller rotors would make this better. A couple of small improvements that we could have to the drone would be to make designs for attachable arms of several different types of drones, have different size rotors for different size produce, and to automate more of the drone's functions because the drone still needs a pilot. Now I'm going to hand it over to Jay to talk about the teamwork dynamic.
Thank you, Stephen. I'm going to wrap it up now. In overall, our design team worked together. Our design team were all engineering students, but they were from different disciplines like electrical, mechanical, computer systems, or biological. Each member of the team contributed from their own standpoint to come up with the design. We did several meetings for brainstorming. We also did our evaluation of the concepts. We also evaluated our ideas and come up with a final design. Figuring out the dimensions was really hard. At that point, we contacted our instructor several times and come up with the dimensions for every parts. After overcoming many hardships and failure, we come up with the final product prototype. After all, we learned from this project that starting from the simple and keep making the improvement to it is the best way to come up with the best design.